Okay, so here is what we're going to do now. So we've introduced this idea of Bayesian statistics and Bayesian way of thinking. It's literally the way of learning, right? It's a way of saying, right, this is what you initially believe based on the evidence which initially made available to you. You then go out, you sort of find more evidence, you collect more evidence, and then you update it, which ends up being your posterior belief. Okay, so that's the fundamental idea of Bayesian statistics. We're now going to reuse that when we start talking about conditional probability. So even though it looks as if we're starting to talk about something completely different, I assure you we are not. Okay, it's still exactly the same idea. Okay, so here is the idea. I'm going to go around the class, okay, and I'm going to ask us to fill in this table. So this is going to be our class table, right? So first of all, how many females are there in the room? So there's 1, 2, 3, 4, 5, 6 females in the room, okay? So 6 females in the room. How many males are there in the room? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, there's 13. Right, so of the females, can you stick your hands up? So I'm going to ask you, do you prefer statistics? Do you prefer mathematics? Okay, put your hands up if you prefer statistics, just the females. One, Nikki? Okay, good. Which means that 5 of you, the 5 of you that didn't put your hand up, do you all prefer maths? All right, okay. Right, now the males, who prefer statistics? Thank you, Mohammed. And I'll say I prefer statistics as well. I don't, but just to boost the numbers, right? Does that mean the rest of you prefer maths? Right, okay, fair enough. So that's 11, right? Okay, let's have a look. The number of people in the room that prefer statistics should be 3. So Nikki, Mohammed, and me, okay? And then everybody else, all 16 of us, prefer mathematics, which means that there should be 19 people in... 19 people, because there's 18 students and there's 1 of me. Yeah, because there's 2 people that aren't here today. Yeah? Okay, so this is my table. This is my table. This is our class table, okay? You've got 2 variables going on. You've got gender and you've got what they prefer, okay? Males or, statistics or mathematics, okay? So now, given that information, could you answer these 10 questions for me? Okay, so 10 questions on the board. Can I give you 5 minutes? Can you answer these 10 questions? Can you find these probabilities? All right, okay, let's start going through these then. So, what is the probability? So imagine I've got this group here. So we've got this group, and somebody just came in and just selected somebody at random, like shut their eyes and just said, you come with me. What's the probability that person is going to be female? Was it? Good, because there's 6 females and there's 19 people in the room. Okay, so probability they're going to be female is a 6 in 19 chance. What's the probability going to be male? Good, because there's 13 males and there's 19 people in the room. What's the probability that person likes stats? 3 out of? 19, good, because you're selecting everybody, so you're saying 3. Probability they like maths? Good. What's the probability they're female and they like stats? 1 over 19, because there's only 1 person who is female and likes stats. I think it's you, Nikki, and there's 19 people in the room, right? So it's a 1 in 19 chance, okay? What's the probability they're male and they like stats? 2 out of 19. What's the probability they're female and they like maths? Yeah, there's 5 females who like maths in the room, and there's 19 people in total. What's the probability that they're male and they like maths? Good, 11/19. What's the probability that they're female or they like stats? What do we reckon? Why is it 8, do you think? Wait a minute.
There is 6 females and 2 males for statistics.
Yeah, absolutely. Yeah, so it's 8. Because female or they like stats. Well, look, there's 6 females in the room. So there's 6 females in the room, so you need to look at all of those females. Or what's the probability they like maths? Okay, so the probability they like stats. There's 2 which haven't been included there. One of those females has already been included up here. Does that make sense? Yeah. What's the probability they're male or they like maths? Yep, absolutely. So it's 18, right? Yes. Is that okay? Good, fantastic. Can I draw your attention to the next question? This one here. What is the probability that a student prefers maths given that they are male? Okay, so I've told you that whoever gets selected and taken out of the room is a male. What's the probability that that person prefers maths? 11 out of 13. Okay, so we need to think about this a little bit more carefully. First of all, I'm going to introduce you to some new notation. Okay, so rather than writing this a big long sentence, okay, so this is question 11. What's the probability that a student prefers maths given that they are male? Okay, so I want to find the probability, so P of, so probability of, okay. I want a probability that they like maths, okay. So in the probability they like maths, but I'm giving you that they are already male. Does anybody know how I write given in shorthand notation? It's that line there. Okay, so that line there literally means it's given to you. Okay, so literally the way which I read that, read from left to right, probability that they like maths given that they are male. Is that okay? So shorthand notation makes it quicker. Okay, and you're absolutely right. I did hear it, but let's just make sure we're all okay. So I'm giving you that they are male. So I'm giving you that we're looking in here. Okay, we don't care about what's happening with the females. Okay, we just care about what's happening with the males. So what is the probability that they like maths? Well, there's 11 of these males that like maths, and there were 13 males to start with, so it must be 11 out of 13. Does that make sense to everyone? Cool, fantastic. Okay, so can you have a go at questions 12 and 13 for me? So can you find the probability that they like maths given they're female and the probability that they're female given they like maths? Okay, so what do we reckon then? What's the probability that this person likes maths given that they're already female?
5 out of 6.
Good, because you're only looking at the females row, so 6 in total, and 5 of those females like maths. Okay, so it's going to be 5/6. What's the probability that they're female given they like maths? Good, because now you're looking at the maths column, right? So you're looking at the 16 people that like maths, that's given to you, and there's 5 of them that are female. Okay, so it's going to be 5 in 16. Does that make sense to everyone? This idea of conditional probability, yeah? So I'm giving you a condition that's true. Now what's the probability that this is true? Is that okay?